Hi, I'm Amanda,
And I'm Michael.
and today we will be presenting about database forensics. First, we will talk about what database forensics is. Next, we will talk about the common database vulnerabilities. After that, we will talk about why it is important to an organization, followed by a case study, and then actual process, and finally wrap it up with the popular tools and how to mitigate a breach.
So, not a lot of lit review is out there yet on database forensics, which seems a little odd now that security is one of those big buzzwords out there. However, even though nobody really writes or talks about it, all big companies have employees who actively perform database forensics. For example, EY has a fraud investigations and dispute services team, Amazon hires security consultants, JP Morgan Chase has data protection engineers, Lockheed Martin, they employ cyber intel analysts, and Apple has forensic auditors. Database forensics refers to the branch of digital forensic science specifically related to the study of databases and the data that they keep. Database forensics looks at who accesses the database and what actions are performed. As most organizations have their data stored in digital format, there is a need for forensics in order to restore that data if lost or damaged. Damages could either be from hardware or software. However, there's a need regardless to reconstruct that data from damage or breach. Investigations use database contents, log files, metadata, and in-RAM or volatile data to rebuild a timeline of lost information and recover it. Databases are usually prime targets to attackers, and access to any database could severely cripple an organization.
Databases are usually a key target for cybercriminals due to the value of information they contain in them. The most common cause of database vulnerability is a lack of due care at the moment they are deployed. Insider threats are a major concern when it comes to database frauds or tampering with data. Unauthorized access to data and attempts to damage or destroy data is a more commonly occurring problem. When employees are provided with excessive database privileges, these privileges can be abused. Many companies also fail to handle sensitive databases, thus exposing them to threats. SQL injections are one of the more popular attacks on enterprise databases. SQL injections attack traditional databases, and NoSQL injections attack big data platforms. Applications are attacked by injecting malicious SQL code, which could bypass system authentication and provide complete access to the attacker. SQL injection can also be used to add, modify, and delete records in a database, thus affecting data integrity. Another outside threat that database managers don't always consider is when there is no need for an old database and it is forgotten and not deleted properly. This can allow an attacker to potentially gain sensitive information about an organization. Computer forensics is a very important branch of computer science in relation to computer and internet-related crimes. Earlier, computers were only used to produce data, but now it is expanded to all devices related to digital data. The goal of a database forensics is to perform crime investigation by using evidence from digital data to find who was responsible for that particular crime. A forensic investigator might examine all transactions within a database system or application over a specific period of time in order to identify any fraudulent transactions. Database forensics assists us in learning where a breach came from.
A specific case study that showcases how database forensics was helpful to help solve a crime can be seen from the Visa MasterCard breach of 2012. This breach involved 10 million people's data that was being compromised that could potentially allow the cybercriminals who caused the breach to create counterfeit credit cards. Analysts who responded to the breach were able to examine the compromised users' purchase data and transactions from Visa MasterCard to narrow down the location of the breach. Eventually, a common pattern emerged, and it was found that Global Payments Incorporated, a credit card processing company, was the source of the breach. That case study highlights the role that databases play in digital forensics. Databases, tables, and metadata hold more usable information than regular computer files do, which helps investigators create timelines and link activity to actors. More specifically in regards to the digital forensics process, there are four major steps: acquisition, examination, analysis, and the report. Acquisition is the process of collecting evidence and preserving its integrity. The examination is when the evidence is actually looked at, which is where database forensics plays its role, which we will get into in our next slide. Analysis is taking that raw data that was found in the examination process and making sense of it. And finally, it all gets compiled in a report that is either used as part of the investigation for an organization or as a legal document to be used in a court of law. When talking about the database forensic process, there is not a set industry framework. As we were researching the topic, though, we came across a proposed process. Developed by Kanji, Katak, and Hasid for the 2015 IEEE International Conference of Computer Systems and Applications, their process involves three phases. Phase 1, Audits and Logs. Two major concerns of databases are storage space and time consumption. A balance needs to be struck when choosing how many logs are enabled on a database for the sake of forensics and for the performance of the system. In this slide are two examples of default log settings for a MySQL and Oracle database. The charts describe the intended usage of the logs and what the possible forensic aid would be if they were enabled. Phase 2, Forensic Techniques. Once a breach occurs, the second phase starts, which involves the actual forensics. LogMiner utility is an Oracle-based tool that parses redo logs. MySQL bin log utility is a MySQL tool that parses bin logs to view changes to server ID, what operations are executed, values inserted on which table, and the timestamp of when all these activities took place. A forensic tool WinHex can be used to view InnoDB files which are saved in a .frm format, which define the format and definitions of objects in a MySQL database at the data block level. As a side note, for those who do not know what InnoDB is, it's a storage engine in a MySQL database. Getting back though to the .frm files, you can compare current data sets with these files at the data block level, again using WinHex to see if there was tampering involved, as one example of a forensic approach.
Phase 3 involves identifying what new tools can be used in the future as part of the process. For example, the Forensic Toolkit. It is a leading digital forensic tool in the industry. It is built for quickly sorting large amounts of data and recognizes the most common database file formats. It is a commercial tool and is roughly $1,000 for a year's subscription or $3,000 for a perpetual license. The Digital Detective Blade is a carving tool that has mobile data retrieval capability and the ability to retrieve SQLite data. It does not have a file viewer, so it must be used in combination with another tool like the Forensic Toolkit, Autopsy, or EnCase. The other popular forensic tools for databases include the Kernel Database Recovery, SysTools, SQL Log Analyzer, SQL CMD, and Windows Forensic Tool Chest. Finally, we will end on what steps an organization can take to mitigate the chances of a breach and having to resort to database forensics in the first place. 1. Identify your organization's vulnerability and invest in security hardware for your systems. Update softwares and ensure there aren't any weak patches. 2. Educate employees on the proper handling of sensitive data. Grant employees access to sensitive data only when required and maintain records that determine who has authority to it. 3. Train employees on risk mitigation techniques and how to identify the more common cyber threats. 4. Reduce the likelihood of a breach and ensure your data is encrypted and archive external databases. Purge your data when the need for it has declined. Finally, here are our references. We hope you enjoyed learning about our advanced topic. Thank you.